Let us look at our topic of the mole concept. The mole concept. Oh, this is a topic which we are going to learn, and what we learn at one particular point will be used again. So it moves in some kind of a chain. What we learn right now, we use it in the next part for understanding the next concept. Meaning that if you don't understand a concept here, this one you will also not understand it. So we must pay enough attention to every single part of the mole concept. So let us start by looking at what we call the mole. This is a seemingly new word to many people, but it is something very simple. So let us, if we want to understand the mole, let us first understand these words here. We have what we call a pair. A pair. This is a word which stands for a quantity, a particular amount of a substance. So in a pair, we have got two items. We have what we call a dozen. When I talk of a dozen, I refer to 12 items. A pair, a dozen. So these are units of quantities. A pair has 2 items, a dozen has 12 items. Then let us bring what we call a mole. A mole is also a unit of quantity. So in 1 mole, we have as many as 6.02 times 10 raised to power 23 items. Oh, this is a very big number, which we cannot just mention at once, but we have to remember this value here, 6.02 times 10 raised to power 23 items. Now, in chemistry, we don't deal with any item anyhow, because if I talk of item, I can refer to anything. So in chemistry, we deal with what we call particles. We deal with what we call particles. Remember, chemistry deals with the study of matter, and matter consists of particles. The particles we deal with in this case in matter are, we can deal with what we call atoms. Atoms are particles of elements. We have got what we call molecules, mostly for covalent compounds. We have got ions, and we have got electrons. So a mole consists of 6.02 times 10 raised to power 23 particles, and can be 6.02 times 10 raised to power 23 atoms or molecules or ions or electrons. So you can see, whereas a pair refers to 2 items, a dozen refers to 12 items, a mole refers to all these items here, 6.02 times 10 raised to power 23 particles. And these particles are these ones that we have seen. So this one gives us now a definition of what we call a mole. A simple definition of a mole is that a mole is an amount of a substance which contains 6.02 times 10 power 23 particles. An amount of a substance which contains 6.02 times 10 to the power 23 particles, and the particles are these ones that we have listed here. So that's what we call a mole. Now let us look at the 6.02 times 10 to the power 23 particles that we have talked of. That's the number of items or the number of particles in 1 mole of a compound. So this number here was established by the father of the mole, a man called Avogadro. Avogadro. So this one here, since it is a constant number of particles in 1 mole of a substance, this value here is called Avogadro's number, or what we call Avogadro's constant. And it is denoted by N, A, or capital L. That is Avogadro's number. This is the number of particles found in 1 mole of a substance, and it is what we call Avogadro's number or Avogadro's constant, denoted by N, A, or capital L. That's Avogadro's number. So don't forget that this is what we call a mole, meaning that if I have 1 mole of sodium atoms, the 1 mole of sodium atoms consists of 6.02 times 10 raised to the power 23 sodium atoms. When I talk of 0.5 mole of potassium ions, this is how we present potassium ions. So 1 mole of 0.5 mole of potassium ion consists of 0.5 times 6.02 times 10 raised to the power 23 potassium ions. When I talk of, say, 0.1 mole of water molecules, this one also contains 0.1 times 6.02 times 10 raised to the power 23 water molecules. So this is how we can get the number of particles of substances in different number of moles of those substances. So as we have seen, 1 mole of sodium atoms consists of this. Of course, times 1, this is exactly 1 mole. When I talk of half a mole of potassium ions, it will be half of this number. If it is 0.1 mole of water molecules, it will be 0.1 of the Avogadro's number. So that is how we can get number of particles in some number of moles of substances. So that's what we call a mole. An atom amount of a substance which contains 6.02 times 10 to the power 23 particles. And that number is what we call Avogadro's number. So these particles, we said they can be atoms, they can be ions, they can be molecules or electrons. And that's what we call the mole. So putting that one aside, let us look at something else, what we call the relative atomic mass. Relative atomic mass. Relative atomic mass. And relative atomic mass is denoted by RAMOAR. That's what we call relative atomic mass. Now, for us to understand relative atomic mass, we need to firstly digest and look at. Let us pick one atom. Let us pick a sodium atom. Now, in an atom of an element, we have got what we call subatomic particles. Subatomic particles. And those subatomic particles are the protons. We have got the neutrons. And then we have got the electrons. So if I pick a sodium atom, we have got protons in a sodium particle, we have got protons being 11, neutrons in a sodium particle, we have 12 of them, and then electrons, we have also 11. You can see here that the number of protons and electrons are the same. We have equal number of protons and electrons. 11 protons and 11 electrons. And then neutrons are 12 in number here. So I want us to look at the magnitude of mass of each particle. So let us look at the magnitude of mass of each particle. So a proton has a mass of magnitude 1. A neutron also has a mass of magnitude 1. An electron has a mass of magnitude 0, meaning that an electron has got a negligible mass. So if we look at the total mass of protons in a sodium atom, here we have got 11. In neutrons, we have got also 11, the total magnitude of the total mass. And for the electrons, the 11 electrons, each with a mass of magnitude 0, it also has a total of what? 0. For the 11 electrons, the total mass is 0. That means that the mass of an atom is due to the number of protons and neutrons in it only, not the number of electrons, because an electron has a mass of magnitude 0 in this case. So, for a sodium atom, if I'm to look at